D is member of the team. So my name is Omar Shahil Bezul Fadilah. Matrix number 2020 877 276. My partner is Adam Haikal bin Halim Abdul Halim 2020 833 794. And next is Muhammad Fakru Aiman bin Abdul Ghani, matrix number 2020 475 954.
Okay, for the first, the background for innovation. Since the beginning of time, clay brick has been one of the fundamental building materials utilized in construction projects. The country's supplies of alluvial soil suited for creating bricks are rapidly running out due to the steadily increasing demand, which is currently in the range of 700 million units per year. Since at least Roman era, clay brick material has been utilized as concrete aggregate. In contemporary times, brick aggregate is occasionally utilized as a medium weight aggregate for structural concrete and in some refractory concrete. Clay brick are made by drying and firing raw material made of clay or shale to create a sintered porous structure. Similar to this, pelletized clay or shale that has been dried and sintered might result in an usable aggregate, especially if the source material can be blown. Some types of clay or shale contain organic or uh, mineral materials that can be released gases upon heating, causing the pelletized particles under the right circumstance to blow or expand. This process results in lightweight expand clay aggregate, or we call it as LICA. A sintered strand has been used to crush, pelletize, and expand coal measures, shale, and colliery waste. Hardened sinterate products can be crushed instead of pelletized to create a more angular product, but the nearly spherical pellets have a tendency to form a dense outer coating over the cellular interior, which reduce waste absorption at least initially and improve the workability of the code aggregate in concrete. For the example of the building in Roman area, which is the Colosseum. And for the additional notes that I add in the slide, here's the alluvial soil. It's a fine grained, fertile soil deposited by water flowing over the floodplains or in riverbeds. Next, for the the usage of innovation material as an aggregate in concrete mixture. By producing concrete, the intention is to use as much aggregate as possible, as this material is cheaper than the cement binder. This means the maximum possible aggregate size, which is we use the clay brick as our aggregate, and should be used with continuous grading of particle size from fine sand up to the coarse aggregate. Aggregate occupies between 70% and 80% of the total concrete volume. And because of that, the strength of aggregate is very important to the final strength of the concrete.
Next is advantage of users innovation materials. So first, increase the strength of concrete. Because clay brick has its own strength, then so mixture with clay brick can reach 15 MPa and 20 GPa. Second is easily obtainable and environmentally friendly. Clay brick as an additional material of this concrete mixture can be taken from construction rubbers, thus reducing construction waste. And third is advantage to consumer. They are water resistant and impervious to all weather. The impact of uses innovation materials. So first, for the economy, is the best product to generate our economy. It is high demand in building construction, and their price in the market are very affordable. And for the environment, it could reduce the amount of conserved natural resources. And next is reduce environmental pollution by reduce construction waste.
For the preparation of material, first we need to calculate all the required cement, sand, gravel, and water required to produce concrete using mixed design process according to BS5 328 1981. Second, we weight all the material according to mixed proportion for cement, sand, and coarse aggregate for a specified volume of concrete. And third, note the room temperature and relative humidity. For the fourth, wipe the laboratory pen mixer with a clean cloth to prevent cement and fine aggregate being stuck to the inner surface of the pen while mixing. Next, mix the dry constituent truly to get a uniform color, then add water. Next, feed sand into the laboratory pen mixer, a part of coarse aggregate, cement, then the water, and finally the remainder of the concrete aggregate, so as to break up any modulus of mortar. Lastly, next, let the mixing time be 1.5 to 2 minutes after all ingredients are added. Ensure about 20 revolution of the pen mixing. And lastly, stop the mixer. Next, for the method of casting concrete and pouring fresh concrete, first we need to clean the cube mold and spread a thin layer of all of the surface of the inner side. And second, fill the cube mold in a layer as approximately 1/3 of the depth of 3 layers each cube. Compact each layer by hand or vibrator. When compact by hand, apply stroke of the bar in a uniform manner over the iron section of the mold. When compaction by vibration, compact each layer by means of electric, pneumatic hammer or vibrating table until the specified condition is attained. Third, after the top layer has been compacted, finish the surface of the concrete in level with the top of the mold by means of the trowel. Cover the mold with a damp sack and store the test tube. After 24 and 1.2 hours of storage in moist air, demold the specimen, mark the specimen for letter identified in a suitable manner. Immediately submerge the specimen in water contained in curing tanks unless required for the test within 24 hours. And for the lastly, do not allow the specimen to become dry at any time until they are taken to be tested.
Workability of fresh concrete test slump test cone. The diagram on the slide shows the slump test cone on fresh concrete from a mixture of crushed clay brick. The test results show that fresh concrete experiences shear slump. Based on the study, this happened because the ratio of water is slightly more and the quantity of aggregate is not enough. Next is for the compressive strength. For the test, two types of specimen, either cube of 15 by 15 by 15 cm or 10 multiply 10 and multiply 10 cm. It is depending upon the size aggregate are used. For the work, cubical mold of size 15 by 15 by 15 be used. Next, this specimen are tested by compression testing machine after 7-day curing or 28 days curing. Load should be applied gradually at the rate of 115 kg per centimeter square per minute. Till the specimen fail, load at the failure divided by area of specimen give the compressive strength of the concrete.